If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture in intermediate level. So in continuation of our discussion for different types of functions. So today we will discuss unit step function, exponential function and logarithm function. Okay, then let's see all this. Now unit step function, what is this means? This is denoted by this one, y equal to u. Significantly it means unit step, x minus a. That means beyond a it is 1 and before a it is 0. That is the meaning of this one. If I say only ux, so you think that a is 0. So before 0 it is 0, after 0 it is 1. If I say ux minus a, so it will take care of that a. So before a it is 0, after it is 1. So again this point is not there. At a it will be 1. At a also the output is 1. So its domain is any r you can put, but here it will be 0 and the range is only 0 and 1. Now what is exponential function? I think you have seen y equal to e to the power x or anything to the power x, that is a to the power x. This is known as exponential. A can take any value. Generally we write e to the power x. If a becomes e, then it is known as e to the power x, where e is exponential number like your pi, whose value is 2.71, 1282, 1282, it repeats. So something of this fashion, which is known as which is a constant, which is greater than 1 e. So if a is greater than 0 or y equal to e to the, both will give you same type of graph, because your base is greater than way. So make this correction. If it is greater than 1, so your e is already greater than 1, so that's why it will come into this box. So if you draw the graph of this one, you see if you increase, suppose it is 2 to the power x, or you can take 2.71 to the power x. So if you keep on increasing power, so output will also keep on increasing. And if your x is 0, then e to the power 0 is 1, or something to the power 0 is 1. So it will go to 0, 1, and if you reduce it, it will get reduced. If you take negative, it will be further reduced. If you keep on increasing, it will move on increasing. Now if your a is less than 1, suppose it is half to the power x. So now if you keep on increasing, fractional power, if you keep on increasing, it get reduced. If you do square of this one 1 by 2, then it is 1 by 4. It is getting, so it will get reduced. So you can see now it is reducing 1. Why this side it is coming like this? Because this is negative, so minus x means it will take it up. So if you took 1 by 2 to the power minus 2, so it will be actually 4. So here it is, that's why it is more than 1 here. And if you increasing it from at 0 it is 0, 0 it is 1, a to the power 0, half to the power 0, 1. If you keep on increasing fractional power, then it will keep on reducing. So that is the graph for exponential e to the power x, but here base is less than 1. Here base is greater than 1. So e to the power x is this graph always, because e is always greater than 2.1. So e to the power x is always this one. A to the power x, if a is greater than 1, this. A to the power x, if a is less than 1, then it is this. Make this correction in the notes, please. So this graph, either y equal to e to the power x or e to the power x when a is greater than 1. Every time I am doing the mistake. We just made these corrections. If a is greater than 1, then domain you can see all are. And output is always only positive values. It cannot even reach 0 also. Because for 0 you have to put infinity, minus infinity. It cannot be possible, because you have to put real numbers. So it cannot put 0. E to the power 1 by x or a to the power 1 by x where a is greater than 1, same. But here you cannot put x 0. You can see if it is 0, then it is undefined. So all real numbers you can put, but except 0. So your output will be, because you cannot put 0, the e to the power 0 it cannot be possible. So your output cannot be 1. So it will be all real numbers, positive values only, because you are taking power of a positive number e. So output will be positive, but in the power you cannot put 0, so the output cannot be 1, because e to the power 0 is only 1. And if it is less than 1, again this graph, entire x is possible, but output is again r plus. Now if you come to logarithm function, so let me explain little bit of logarithm here. Suppose 2 cube is 8, then we say log 8 to the base 2 is 3. So for logarithm function, it is always a should be greater than 0. The base is always positive. Base cannot be negative. That is defined for, by default it is for logarithm function. So here a to the power y is equal to x. If it is, then we say log x to the base a is y. Or we can say y equal to log x. That is the meaning of this one. A cannot be 1, because if it is a is 1, now we can say a square is also 1, a cube is 1, a to the power 4 is 1. A, then any power is 1. Actually this is my input, this is my output. So this is input, this is output. So 1 is input, output is 2. Again 1 input, output is 3. Again 1 input, output is 4. For all input, one input, there are different output, which is not a definition of function. From one, you cannot be Christian, you cannot be Buddhist, you cannot be Hindu at a time. So this is not possible. So that's why it is not, a is not equal to 1. So these things you have to remember. The base cannot be 1, the base cannot be 0 for logarithm. Now if you see this one, there are two graphs again for E. If a is greater than 1, if your base is a suppose 2 greater than 1, so it is 2 to the power 4. You can see 2 to the power 4 is 16, 2 cube. So if you increase your x from 8 to 16, then your output is also increased 3 to 4. This is my input, this is my output. This is my input. If my input is 1, then output is 0 because 2 to the power 0. So if my input is 1, then output will be here 0, no y. You can see negative also. If your input is half, then output is minus 1. So negative values. If you give input fraction input, then it is negative log. So that's why this is the graph. If you give x fraction, then y is negative. If you give 1, then y is 0, then output is 0. If you keep on increasing, then it is increasing. 8, it is 3, 16, it is 4. So this is the graph for y greater than a greater than 1. Now if your a is less than 1, suppose half. So half to the power 0 is 1. Again, if your input is 0, input is 1, then output is 0. Okay, so it will go to 1, 0. Now input is 2, then your output is negative. So if you keep on increasing from 1, if you give more values greater than 1, then your output is negative. So the graph is reverse. And the values, if you give less than 1, suppose it is 1 by 4, then your output is positive 2. So it will come like this. So this is the graph for log x if a is less than 1. Now generally, if I say log x in mathematics, in physics it is different. Physics they are defined in log e to the base e as a ln, that is natural log. But in math, so if I say only log x, you think that base is e. If it is not mentioned specifically, only log x means by default we always take it e. But in physics applications, you will find log x, if nothing is mentioned, then they take 10. And for ln, they have, if they write ln, that means e is there. But in math there is no ln, only log. So log means base is always e if it is nothing mentioned, where e is this one. Now again for domain, you can see if a is greater than, every time I am writing, oh that is okay, that is for log x I am just writing, okay. For log x, any log x, either this or this, your out domain is, you have to put only positive values. You can see I am not putting, this x cannot be negative. So this x should be always positive. Because base is positive, so anything power you take base, output will be always positive. So that input x, it cannot be negative log x. So your log x input is this one. And your range, you can see anything in y you are getting negative y, you are getting positive y, you are getting 0 also. All y's are possible. Now if it is in logarithm, there is a different very interesting property. You can change this base and this. If log a to the base x is 1 by log x to the base a. How come this is possible? Because it is possible if you take this one. If it is 1 by 8, then it is 2p cube equal to 3. And 8 to the power 1 by 3 is also 2. So now you can see, if this is my input, this is my output y. And base was this one. So input and base. Now if you change this input, now your input is this one and base is this one. So your input and base is changed, but your output, what happens to your output? It get inverse. In place of 3, it is 1 by 3. So that's why if you change your input and base, so it get reciprocal 1 by this one. So 1 by this one is this. So you can change. If you change this 2, that means it will be reverse 1 by reciprocal. So again, these conditions is always there. If there is a log a should be greater than 0, a cannot be equal to 1. So these are always there. Again, what is the here? You cannot put, you can put any value, but the output should not be 0. When your output is 0, when your x becomes 1, so you cannot put 1. When your x is 1, then your output is 0, so you cannot put 1. And your output can be any real number, but it cannot be 0 because you cannot put 1 here. For 0, you have to have, it has to be infinite. You cannot go infinite here. So that's why 0 is not possible. If you like the video, then press the like button and please give your valuable comments in the comment section.